Hi there, welcome. It's time for Physical Sciences. My name is Tinyiko Kosa. You can call me TK. And once again, I'm bringing you a great lesson in Physical Sciences. And today, like we always do, we're taking you from grade 10 to grade 12. So if you're doing Physical Sciences and you are in grade 10, 11, and 12, this is for you. I'm going to start today's lesson by looking at waves, which is based on at grade 10 level, but we're going to stretch the lesson until grade 12, where for grade 11 and 12 we'll be talking once again around redox reactions. Okay, now like I'm saying, we will start by talking waves. What is a wave? A wave is constituted by a regular repetitive motion. Okay, and we have got two types of waves. What are they? We've got what we call transverse waves, and we also have longitudinal waves. Okay, now let's look at what the transverse wave looks like. A transverse wave is a wave in which the disturbance is at right angle to the direction of the wave. And this disturbance here, if we're talking about single disturbance, okay, if we're talking about a single disturbance, we call this a pulse. Okay, now for transverse waves, the displacement of the medium is perpendicular to the direction of the wave. Okay, so they move like that. If this is the direction of the wave, the displacement or the disturbance will be in that way, so that the two are perpendicular to each other. Okay, a ripple on a pond and a wave on a string are easily visualized as a transverse wave. Here is a drawing here of a transverse wave. You've got this drawing there. Okay, that's a transverse wave. Okay, now the displacement, now from there to there, that is a displacement from the rest position. This is the rest position of the wave, okay, or the equilibrium position, some people will call it that. And that maximum displacement there is called the amplitude. So I'm going to talk to this a bit more later on as well, amplitude, okay, and other things. So if the direction of this wave is this way, so there's going to be a velocity, or the speed with the direction of where the wave is going and how fast it is moving, right? And transverse wave may occur on strings, may occur on surfaces, and may occur on solids, all right? Like I said, the displacement, the disturbance and the direction of motion of the wave are at right angle to each other. This is what is showing us. This is the direction of disturbance. This is the disturbance, okay? And that is the direction of the wave. Okay, now continuing with transverse waves. Transverse waves cannot propagate in a gas, liquid, because there is no mechanism for driving motion perpendicular to the propagation of the wave. Okay, so looking at the transverse wave again, continuing to look at the features of the wave, like I showed you earlier on that drawing, we have something called the amplitude. This is the maximum displacement of the wave from its rest position or equilibrium. So from that wave that you saw there, if I have got that and that was the rest position, that maximum displacement there is called the amplitude. Okay. Now the pulses, which are the disturbances of a transverse wave, are called troughs and crests. Now troughs and crests, I tried to draw a wave there, wave motion, transverse wave. If this is the rest position, that's the amplitude. Of course, they should be equal. This top one here will be the crest, and this will be the trough. The bottom one will be what we call the trough. Okay, so this is what we mean by crests and troughs. right? Now, a pulse, like I've already defined it, it's a single disturbance that constitutes a wave motion. And lastly, we're looking at something called the wavelength. This is the distance between two consecutive crests or troughs, okay? Two consecutive crests or troughs, okay? And here, what do we mean? You can define a wavelength as a distance between 2 points on a wave that are in phase. This is another way of saying it. Now, this would mean if I have this wave here, from the distance from the peak of that crest to the peak of the next one, this distance here constitutes the wavelength, which is symbolized by the Greek letter lambda. So that's it for this section. See you in the next section of the lesson.